Let's look at this. So we want to rotate this around the x-axis. What's the function here? What's the, well, the relation. It's not a function. It's here. It's equal to 4.
Wait, I mean, solve for y. Y equals something x.
Okay, so which one are we going to go with? We want, yeah, we're going to x equals. So no, x. Yeah, we want it about the x-axis, so we want it in terms of x. So here's my function. I want to write this in terms of x. I want y isolated on its own on the left-hand side, because we usually do y equals and then, yeah. So that's the first thing we're going to do. We're going to, well, I think it might be easier because we're going to have to square root this. If we do this and then square root both sides, yeah? So y minus 3 is equal to the plus minus square root of 4 minus x squared.
Wait, why can't you square
root
straight away from the top?
Here?
Yeah. Oh. Square root of 4, no?
What's the square root of this side then?
Square root of x
Plus y minus 3.
All right, so you're... yeah. Yeah, you would have the square root of x squared plus y minus 3 squared, which isn't x. Yeah, okay. Yeah. So it's better. Yeah, you can't just do that, no. Okay, so we have this. This is our relation. Now, why is there a plus minus there? Yeah, because it's a root, yeah, but it's not all one function. If you think about one, it's like a half a function. One is going to be this bit, because it doesn't pass the vertical line test, does it? So there's two functions within this. That's why they call this a relation, not a function. So we have to use the upper one and the down one. All right. So our plan is here to integrate this and rotate it around. So it's one of, there's two functions here. There's y is equal to 3 plus, which is the above one, I think. And then we have y is equal to 3 minus 4 minus x squared. So these are two different functions. You go on y1, y2 if you want. And we're going to have to subtract these and integrate like we did in the previous example. Okay, let's do that then. Let's set that up. So we're integrating. We're going to take 3 minus root 4 minus x, oh, it's plus, is it? Plus. That's the one above, squared. So fx, one function squared, minus the other function squared. Is that? Same thing we did in the previous example. We have two functions. One's above, one's below. I'm just presuming the plus one's going to be the one above.
So what happens if
You'll get a negative and then you'll get the wrong way. You get the same as you got in the previous example. And then you just get the negative and then it'll be okay. Yeah. Okay, so this is like we did in the one we rotated a minute ago. But it just, so in the one we had a minute ago, it was, what was it? It was root x squared minus x squared squared. We did these two functions. We had the pi outside. So we need a pi outside here. I'm going to make this question a little bit easier. Yeah.
Is this an SL topic?
No. This is a really difficult HL question. And you'll see why in a minute. It gets even more difficult when you come to actually integrating it. Like we have to integrate this in a second. With respect to x, yes, I'll put the double brackets here. I'm going to do something here that's going to make it a little bit easier with the bounds. First of all, we need the bounds with the x-axis, so we need here and we need here. Do we know what those points might be?
No. 2 and -2.
Yes, 2 and negative. Very good.
Hey?
Oh, that's the radius. The diameter is 4. So then if you do it.
What's the radius? So the radius here is 2. We can see that because this is 3 to 5, yeah? Yeah? So the radius is also 2 here. So it's right here. The center is here. So 0, 2, yeah, okay. 0 and 2, yeah, all right. Okay.
You calculated it ahead.
Right. I'm going to write this down and see can you figure it out. I'm going to go from 2, and to make it easier for myself, I'm going to go to 0.
Oh, so one of them.
And I'm going to double it.
What?
So what I'm going to do is I'm going to get this one and this one. I'm going to get that, and then I'm going to double that. I'm going to go just from 2 to 0 because it's easier.
You can only do that with symmetrical.
And then, yeah, only when it's symmetrical, yeah. So I know it's a circle, I know it's symmetrical, so I can just do the semicircle and then double it.
This is disgusting.
Okay, that was to make it easier because subbing in 0. You don't have to do that. You could do -2 and keep this as 2. But I know it's just 2 of these together, 2 semicircles. Right. What do I do here to square this out?
You do 9 plus.
Yeah.
You're gonna like bracket.
Yeah, you got to do it slowly and do it correct. Don't say that this square just disappears, the square root, and then it's 9. Right, so it's 2 pi between 2 and 0. And the first is 9 plus 6 root 4 minus x squared plus 4 minus x squared. Do we see that? That's this multiplied by itself. FOIL method or whatever method you use. And from that, I'm going to subtract.
First, outer, last. No.
Yeah, inner last. Yeah. First, yeah. Yeah. I'm going to get rid of this. Okay. I'm going to need the space, I think. So this one would be quite similar. I think -6 in the middle. -6, 4 minus x squared. Also plus 4 minus x squared, yeah? Dx. Okay. So I'm going to subtract these two and hopefully things calm down a little bit. I think the 9s will disappear. I think the 4s here will disappear. And I think the x squareds are going to disappear because it's subtraction. So the same.
12.
And 12, yes. Okay, so it's looking a bit nicer. From 2 to 0, 2 pi, I have 12 root 4 minus x squareds dx. And actually the 12 can come out to be 24, can't it? 24 pi. The 12, yeah. 4. All right, very good. Okay. And now we have our next problem. Our next problem is we're unable to integrate this by rule because that's not ax plus b, that's x squared.
Oh no!
Yes, indeed. So our next problem, this way it's a HL question. This way it'd be a great question for an IA, something similar.
Substitution.
Yeah, we do have to substitute, but what we need to think about is what could I substitute in for x
To get 4. X.
that would combine it in. So at the moment we have 4 minus x squared and we have to square root it. What can I substitute in for x that could end up with something squared that would cancel out the square roots and I'll just left with something I can do?
0.
What part of the course did we have? No, it's not difference of square. Yeah, that's a good idea. It's not. It's a good idea, but still, I think it won't work out for us. No.
Do we have to use I?
Think of Titan.
Titan of trig.
All right, trig.
Oh,
Yeah.
trigonometry.
Trigonometry. How can trigonometry?
Alex, come on.
How can trigonometry help us here?
No, let Alex do it.
Alex
do it.
Alex.
Oh, that's
I got this, guys.
And maybe don't think of 4. Think of 1, maybe. 1 minus.
It's R cos.
What if this was something? What would that?
I don't know.
If this was 1 minus x squared, 1 minus x squared, 1 minus, it's going to be sine or cosine or tan or something.
Arc cosine.
So what I want to get is something I can square root. That's what I want. I want to get something I can square root.
Where do you see it, Josh?
On the. This is Pythagorean identity.
Yes, it's Pythagorean identity. So if I say it's, what is 1 minus sine squared x?
Cosine squared x.
Cosine squared x, which I can square root to give cosine x, yes?
Oh my god, that's so sigma.
So, what do I put in for x?
Wait, what happened?
That's what I'm saying. This is example with 1, but I have 4 here. What will I use for?
Divide by 4.
Squared x.
2 sin x.
Yes. 2 sine x. So, I'm going to do substitution. I'm going to say let u equal 2 sine x. Why? Because if this is 2 sine x, or sorry, let x equal, I want x is equal to something.
You can just say that.
Yeah, substitution. Is this why it's difficult?
Yeah.
To find this. What does that give us then? That's the square root of 4 minus 4 sine squared u. I've used u instead of x. Can't use x again. I can take out the 4, can't I?
Yeah.
That gives 2 root 1 minus sine squared u. And sine squared u is, this is cosine squared u. And this 2 cosine u.
You take out 4, right?
I've factored out 4 out of this with square root 4. And square root 4 is 2, isn't it? So I factored that out, yeah.
That's crazy.
Damn.
All right. So that's a little sidebar. But I also I have a problem here because my whole function has been dealing with x. These are bounds on the x-axis. This is with respect to x. Now I've changed the function in terms of u. I have to change everything in terms of u. Which means with integration by substitution at any stage, I'm going to have to derive this. What's the derivative of this? How would I write it here, even on this side? D what over d what?
Half,
Du cosine
half, no, negative half cosine.
No. Before you even derive it, what's this? It's dx over du, yes? It's the opposite around to what we usually do it. X is the function name now. So what's this one then?
It's negative half cosine 4u.
I think it's just 2 cosine u, no?
Divide by
The derivative of sine, derivative of sine is cosine. Yeah. Yeah, you were, yeah. Okay. Which means, Alex, dx is now 2 cosine u du, yeah? Do we see that? With a du, multiply both sides by du. Okay, because I want to get rid of dx as well. What I'm trying to do is substitute into this function.
Oh my goodness.
Right. So 24 pi, I'm going to talk about the bounds in a second, because I don't think I want to put it back into x at the end. I don't think I want to undo this at the end. I think I'm going to stick with u all the way through, which means I have to change the bounds in terms of u as well. How do I change the bounds in terms of u? Well, I have a relationship always between x and u here. So if x is 2, what is u?
2 sine 2.
Yeah. So this is why it could be an IA question. It took me 2 pages to do this out. But how many pages of maths do you need to do in your IA? 2 to 3 pages is fine. So if you did 2 to 3 pages, like one really difficult question of this, got it correct, then maths is spot on. Do it. You can't do this. Well, you could do this exact question, but they tend to say don't do an example that's in the book or from the book. So this is taken from the book. It's just a question. It's not an example. But if you could make your own, like, oh, I wanted to find the volume of a bicycle tire or something like that, and then you plot it on Desmos, and then you say, all right, this is my 2 functions, and then, all right, and then you can even, like, all right, what's the difference in air compression or something like that? You could talk about that, like, depending on altitude or something. You could just bring it a little bit further, and then that's your whole IA done. All right. So, x was 2. What's it now? X was 2. What's it now? So, yeah, 2 sine 2. 2 sine u equals 2. So what's u equal to? So I've let x be 2 here. So 1 is sine u. So what?
U is
Pi over 2. I heard it. Pi over 2. Sine of pi over 2 is 1, isn't it? So this one, the u bound is pi over 2. All right, when x is 0, changing the bound, second bound, 0 is 2 sine u, using my relationship between x and u. So 0 is sine u. Where's the first place? Pi would be one answer, but the first place is 0, yeah. It's easier to use the first place. You'll get the same answer, but easier to use. As in, there's a bunch of times.
Oh, yeah.
Yeah, because we know it goes around the circle. Okay, so we use pi over 2 and 0 as our first bounds. This bit became 2 cosine u over here. Much better. Dx is 2 u.
2 cosine u du.
2 cosine u du.
So it's 4 cosine squared du.
du goes away when you integrate.
Yeah, it is 4 cosine squared du, yeah? I think I got a different answer earlier, so I'm gonna just check. I'm gonna just check. So I know I got it right. It is 4.
Isn't it 8?
I think it shouldn't
Wait,
be.
isn't dx?
No, that's correct. Sorry, it is correct. Yeah.
Isn't 2 sine?
Can we integrate this?
Yes.
No.
Oh.
Close. And we've done one of these before. It was cosine squared. How do you get unsquare? Still using back to identities.
Cube. Over 3.
Cosine squared equals sine squared minus 1.
Yeah, but then you still got.
No, that's the one we've used. It is a good idea, but I think we gotta think another side note over here.
Double angle identities.
It's one of our double angles, yeah.
Cosine squared. 2 cosine squared.
How do we get squared?
You
You would say cosine 2 back to u. That's all that happens.
So you go back, you go to your trig on your formula booklet. You go, right, I want a relationship between that turns cosine squared into a double angle.
2 cosine u.
And I think if you look in your formula booklet, you have this one at some stage.
2 cosine 2u.
2 cosine squared theta minus 1, isn't it?
Yeah.
That one's in there. So what do we have? All right, we don't want 4. We only want 2 of them, yeah? So I'll pull out 2 over here. 48 pi over 2, 0, 2. I think it's easier.
Cosine 2 theta minus 1.
Okay, so cosine 2 theta plus 1 is equal to cosine. All right, do we see this? If I add the 1 over? All right, I'm going to use that here now.
Yep.
All right, I'm going to have to rub out some of this. Go back to the top.
This is actually such a ridiculous question.
Yes, it's a ridiculous question.
How many marks would this be?
So we're not getting this on our test. I'm
Um,
actually crushed.
It could ask you from. I think this. I think it's almost too difficult to ask as is, just the one big question. I think they would break it up a little bit for you, and they tell you to use integration by substitution or some. Usually it gives you the hint. Maybe if it was the hardest question on the paper, it might not give you the hint, but usually it gives you the hint in past cases. What to sub in. If you had this from start to finish, judging by the number of processes, this could be 16 to 18 marks on its own. Okay.
So if you don't know
All
how
right.
to do it, you just lose out on like.
That's why they usually give you some hints and tips about how to start it, and like they break it up into an ABC where hence find, which means they've told you what to do at the start. Oh, find this in terms of y, and so on.
Sorry, Steph,
Ma-
you wouldn't have a formula sheet for HLAI, would you?
No, I only have the AA versions. I can send you a digital one.
So I'll stay.
Okay, yeah, Jake have it. Yeah. Okay. All right, where was I? All right, this has to be replaced with this. Well, obviously this is not theta, this is u. Okay, we're nearly there. So we have 48 pi over 2, 0, 2 cosine 2u plus 1 with respect to u. Okay.
Wow.
Right, we're almost there. We now need to integrate finally. 48 is going to be on the outside, 48 pi is going to be on the outside. What is the integral of 2 cosine 2u?
1 over 2 negative. 1 over 2.
1 half sine 2u, yes, plus u. We're all dealing with u's now. Pi over 2 and 0 to sub in. All right, so let's sub in.
Just pi over 2.
1 half and then.
Well, with sine and cosine, 0 could be 1, of course.
Oh, yeah.
So don't ignore it. I think it might be 0, but we'll have a look. A half sine, so sine pi over 2 gives a half. Well, let's just write it out. Sine pi plus pi over 2. That's with subbing in pi over 2. Minus half sine 0 plus 0.
What is it? Pi plus pi over 2.
Pi 2 pi, yeah, so the 2 and the 2u, 2 times this leaves just pi, yeah?
But what if you add another plus?
U, this has to be sub, yeah. Okay, so what's sine pi? 0. Okay, so that goes away. This is just pi over 2. What's sine of 0? Also 0. It was 0. You're right in the first. So this is just pi over 2 times 48 pi gives 24 pi squared units cubed. And that's the answer. That's correct.